When I personally think about translocations and the benefits that we might get from it, I tend to think of it in three ways. The first one is just from a straight out conservation management perspective. It's that old cliche about, you don't want all your eggs in one basket. And the more populations that you can develop and protect, the more insurance you have against things going wrong. Maybe you get a new disease emerges or a predator outbreak or something like that. If you've got lots of populations, you've got lots of insurance for the species itself. Secondly, we've brought Tautawai or North Island robins back to Shakespear Regional Park. Historically they would have been here. Historically they were once over the entire North Island, but they've pretty much disappeared from the upper North Island after European contact. And the reason for that, of course, is the introduction of pests, particularly ship rats and mustelids. Once we get rid of those pests, we can bring things back, like robins. And the reason we want to do that is, they were a part of that original ecosystem, and they've been missing from these ecosystems for probably well over 100 years. And so ecosystems they tend to be more resilient to change when they have more components to them. So the more different kinds of plants and animals you have in an ecosystem, the more resilient it will be over time. And robins were a former component of this ecosystem, and now we've brought them back. And so they can resume their role within that ecosystem. And what we know about their role is that they're a small insectivorous bird which primarily feeds in the ground. And so we don't know whether they're critical to ecosystem functioning or not. I mean, they've been gone for 100 years, it's hard to tell. But we know that they were naturally once here, and we can reinstore that and let that natural process come in. They would be naturally predators of some invertebrates, they might play a role there, and naturally they'd also be prey. Things like moorporks, for instance, would naturally eat robins. The third and final sort of reason for doing a translocation that I think of is just community engagement. And this is very much a social and quite contemporary sort of outcome of translocations. This park here receives, over 100,000 visitors a year, and a lot of those people will just come to the beach, but some of them will go walking. And when they go walking, there's going to be this confident little bird which they've never seen before, which is going to land in the middle of the track. And they might question that and wonder what it is, and it might well be their first experience with a robin. And I think that's especially pertinent when you look at Auckland City just down the road, where there's, 1.5 million people. Many of them are quite urban, but they use the regional parks a lot. And by putting what used to be here back again, we sort of restore that ecosystem, but we give all those people who live in the city a chance to see what the ecosystem should actually look like. With the robins, we began discussing this a couple of years ago and how it might fit in with a research project I was doing. And the translocation process, really the actual planning begins about a year out, where we assemble a team, we approach the Department of Conservation and we make a formal application to them. We also approach all the other groups which may be associated with both the source site and the release site. And that's typically your iwi and hapu and any other community groups that might be involved. Then it's basically putting together a team of skilled people who know how to catch and safely handle birds. Because the translocation process, it's really stressful. It's essentially the avian equivalent of alien abduction. I mean, those birds are just going about their lives and they suddenly end up in a very, very different situation. And the best way to deal with that is by having really, really skilled people involved. So we go to the site. In this case, what we actually did with the tautawai, or the pitoitoi as they're known down the line, or robins, we actually did 2 trips prior to the translocation where we went down and we trained them. So what we did was we fed them with mealworms, and that gets them familiar with people and means they come in nice and close, and it makes them very easy to catch. So when we went back to catch them, we had some small cage traps called potter traps. They're like a little possum trap. We bait them with a mealworm. The birds are used to us, they're used to being fed, so they very quickly approach us, and we can catch them. Once the birds are caught, they're initially put into just a black cotton bag, which breathes really well, but it cuts out the light and it cuts out anything that might disturb them. The birds then come back to a central processing station, which was run by myself and my brother Graham. And what we do is we weigh the bird, and then we pull it out of the bag and we measure its tarsus, which is its leg, and we measure its wing. And those two measurements together with the weight allow us to make a reasonable guess as to whether it's a male or a female. Males are typically bigger than females, but not all the time. And there's been a bit of research done, and we figure we get it right about 70% of the time. Once the birds are processed, they go into a small box. They're kept in that box for up to 3 days. We can hold them for a bit longer, but we prefer not to. It's obviously not their natural environment and probably not very nice for them. When they're in the box, the birds are fed twice a day. We give them fresh mealworms. We give them a lot more than what they actually could physically eat. But occasionally they surprise us and eat a lot more than you'd expect. Sometimes up to a third of their own body weight a day, which is quite astounding. But by feeding them twice a day, it allows us to monitor their condition and how they're doing. We actually weigh the food in and out as well, so we can tell who's feeding and who's not. Once we've caught our full quota of birds, they then get loaded into a vehicle and transported to the release site. Now, the transportation phase is probably the most difficult in many ways because it's the most unpredictable. You tend to get a bit of noise and vibration and things like that. So for the birds coming to Shakespeare, we specially outfitted one of the Auckland Council vans with a purpose-built frame which had thick sponge under it, so it essentially absorbed any sort of vibration. We also blacked out the windows on the van so that no light could get through, and we left the Mangatutu capture site, we left that very late in the day, so we transported the birds at night when they'd normally be sleeping. With the birds that came from Tiri, we were quite fortunate because, of course, Tiri Matangi, it's just a 30-minute boat trip and then a 10-minute van drive down to the park. So we were able to move the birds on the morning of release and release them on the same day, which is much easier for them. Once the birds are released, that's actually when the hard part starts, because we then have to find them. And obviously you can imagine if you're plucked out of your neighbourhood and released in a completely strange city, you're going to wander around and look for something familiar. And we think that that's what the birds actually do here. They walk around quite a bit, or fly around I should say, and look for something familiar. And they'll do that for a few months, typically up until the first breeding scent.
Yeah, some of them are still in Kopai Glen.
Oh, okay.
But it'd be interesting to know if they're the ones that were released in Kopai Glen.
How far have you searched?
I've done a couple of sections of the Navy land today.
Yeah, okay. Once they've hit that first breeding season, they will normally settle in a territory and they will normally stay there, quite possibly for the rest of their lives. A translocation also gives us opportunity to conduct really good science. And as a reintroduction biologist, a scientist who does translocations, I'm always thinking about how we can improve them and how we can do them better. And I was very fortunate to get a Marsden Fast Start grant from the Royal Society of New Zealand a couple of years ago to allow me to do some experiments around translocations. Now, the prime purpose of a translocation is to start a new population. So the science itself has to fit in around that primary goal. And that always comes first. The only reason we're going to move birds is to try to start a new population. But where we can align science with it, we can get some really nice outcomes. And what I'd always wondered about is when we do a translocation, we often lose a few birds after the translocation. It's very rare for it to happen during the translocation, but after release, some animals just disappear. And I've often wondered about why some animals disappear and about why some animals stay exactly where we release them and why some go a long way from where we release them. And in doing a bit of reading in scientific journals about this, I came across the whole concept of animal personality. which a lot of people think is quite funny. But at the same time, if you took 40 people and you put them in a really, really stressful situation, they're all going to react in a very different way. And everybody knows and inherently understands that. But increasingly what we're finding with animals, and it ranges right through from animals such as us, all the way through to things like freshwater mussels and cockroaches and the like, is that individuals always display individual behaviours, which could be called personality in some ways. And so what I became very interested in was, when we do a translocation, we know we're going to catch a range of different animals. We know some of them will go further than others after release. We know some of them will stay exactly where we release. And we wanted to see if we could identify who those individuals are. The transfer boxes that we used have been wired up with a little microprocessor, and that microprocessor is connected to 3 infrared sensors inside the box. 2 of the sensors are over the perches and 1 of them is on the ground. And what this allows us to do is it allows us to measure how much movement the birds make when they're in the transfer box. And what we tend to find is that animals that move around a lot in a box, that are very, very active, in this case in a transfer box, tend to be very bold and exploratory animals. So they're the ones that are going to go the furthest. And those that are put into a box and stay very, very still, they're the ones that don't go very far at all. And then you'll get other animals that are kind of intermediate between those 2 extremes. So what we're doing with this translocation is quantifying how much each individual moves during the whole translocation process. The other thing that we do is we measure how much they eat. So they get a measured amount of food twice a day, and we keep a full track of exactly how much they eat. We also record when we disturb them. So when a big hand goes into that box and changes their food, we note down when that is and look at their activity patterns before that disturbance and after that disturbance. We also keep data on things like how long they were caught, how long it took for them to be processed, how long they spent in the transfer box, and how they behaved during the different stages of the translocation. Ultimately, what we're hoping to learn from that is, who succeeds and who doesn't, and if we can predict prior to release which animals are going to do well and at which sites. At a site like this, at Shakespear, we talk in conservation biology a lot about connectivity. And what we mean about connectivity is kind of like the motorway system. So the motorway system lets humans get from one place to another. Well, animals also need their own sort of highway, if you will. And for small birds, that means vegetative corridors. And in some ways, corridors are good because it allows animals to move around. But after you release animals, it also allows them to move from good areas to bad areas, which would be areas with pest management, areas without pest management. We're quite lucky here at Shakespeare because there's quite a lot of good habitat within the park, but the connectivity leading out of the park is quite low. So what we're hoping is the really active birds, those bold birds that moved around a lot in the transfer boxes, they'll move around a lot, but hopefully they'll move around a lot just within the park and won't leave. However, I'm also doing experimental translocations at other sites where birds do have the option to leave. And so what we're thinking is, as well as being able to identify which individuals might move and where they might go, this type of work might also give us a better steer on which sites are good release sites and which are not. Basically, isolated sites such as an island or a very isolated mainland site are really nice for releases because the animals can't leave and it's hard for pests to get back in. As your connectivity increases, when you get to really big contiguous forest, it becomes much harder because things can leave and things can re-enter quite easily. But ultimately, what we want to do is do better translocations and do better by the birds. In terms of that social side of a translocation, it's a funny one. Like, a lot of people really grasp the concept of restoring an ecosystem very quickly. I mean, humans have caused a lot of damage, and humans in New Zealand, Māori had an impact when they first arrived. Europeans had a very large impact in a short period of time when they arrived. But through restoration ecology and through translocation and reintroduction of birds like robins, we can kind of make up for a little bit of the damage that we've caused in the past.